Hello, I am Farah Hussein, Chemistry 225 student, and today in my presentation I will present to you the reaction between azoxybenzene and aluminum chloride. So welcome to my presentation. This reaction is significant in organic chemistry as it demonstrates electrophilic aromatic substitution, which is a fundamental mechanism that illustrates how aromatic compounds can react under specific conditions. So in this presentation, we will explore the reaction, and our goal is to observe how these compounds interact and produce 4-aryl azobenzene, which is a colored compound. So first, we will discuss the mechanism behind this reaction, the expected outcomes regarding color change, and the significance of positive and negative tests. And finally, I will also detail the experimental procedure. So the purpose of this experiment is twofold. First, to determine how various aromatic compounds react with azoxybenzene, and second, to observe any color change that may indicate a successful reaction. So the main goal of this experiment is to identify if our tested compound or our unknown contain aromatic compounds or not. If there is a color change, we have a positive test, then it indicates the presence of aromatic compound. Before we begin, let's take a look at the materials we need for this experiment. We will require azoxybenzene, anhydrous aluminum chloride, various aromatic compounds, and optionally dry carbon disulfide if we are working with solid hydrocarbons, and test tubes, and also a heat source if needed. Some examples of aromatic compounds are on this diagram, such as naphthalene, benzene, and there are many other aromatic compounds that we can use in this experiment. Now let's go through the procedure step by step. In the first step, we will place a measured amount of the aromatic compound to be tested into a clean and dry test tube. And after that, we will introduce a crystal of azoxybenzene followed by the addition of anhydrous aluminum chloride. And this introduction of aluminum chloride is vital because it serves as a Lewis acid as it activates the aromatic compound for the upcoming substitution reaction. And after these steps, we will note the initial color at this stage. If no immediate reaction occurs, we will warm the mixture to encourage the reaction and to proceed by increasing molecular movement and reaction kinetics. After that, we will wait up to 30 minutes to allow for the full development of color, and this development of color will serve as a visual indicator for the successful of the reaction. And finally, when we complete the experiment, we must dispose the reaction mixture properly in the organic solvent container to ensure safe handling of potentially hazardous material. In this experiment, we are mainly looking for positive and negative test results. A positive test indicates the successful formation of 4-aryl azobenzene and an aluminum chloride complex, which is evidenced by a distinct color change. Conversely, a negative test will show no color change, indicating that no reaction has occurred. And the positive test will confirm the azoxybenzene has reacted appropriately with aluminum chloride, leading to the expected product formation, which is a colored product. And this rich color will arise due to the electronic transition in the 4-aryl azobenzene structure, which absorbs a specific wavelength of light. However, in the negative test, the absence of color will be due to the lack of the necessary reactivity under the experimental condition, as they do not participate in electrophilic substitution due to their lack of aromatic character. It is important to note that certain complications can arise during this experiment. For example, oxygen-containing functionalities in the aromatic compound can interfere with the reaction and lead to unexpected or confusing color change. So it's crucial to carefully select the aromatic compounds that we use to ensure accurate results. So it is advisable to use pure samples and control for any potential interfering substances, and also it is worth noting that dry conditions ensure that water does not interfere with the reaction, as moisture can hydrolyze aluminum chloride and disrupt the electrophilic mechanism. And now let's delve into the mechanism of this reaction. The reaction between azoxybenzene and aluminum chloride involves electrophilic aromatic substitution, where aluminum chloride, as mentioned in the previous slides, acts as a Lewis acid to facilitate the reaction. So the first step is that aluminum chloride will interact with azoxybenzene. This Lewis acid coordinates with the oxygen atom attached to the azo group, increasing the electrophilic character of the aromatic ring. And then in the second step, the activated aromatic ring undergoes electrophilic attack by the electrophile generated from the aluminum chloride complex. And a sigma complex, which is the arenium ion, is formed where the aromaticity of the ring is temporarily lost. The arenium ion loses a proton H+ to restore aromaticity, and the aromatic system is re-established, resulting in the formation of a substituted product. And finally, the aluminum chloride complex is regenerated as the reaction proceeds, so it can continue to catalyze further reactions. And here in this diagram, you can easily see the three main steps of our experiment. So to recap the main steps, in the first step, aluminum chloride interacts with azoxybenzene, forming a complex. This complex then undergoes electrophilic aromatic substitution when we introduce the aromatic compound, and this leads to the formation of 4-aryl azobenzene. The final step involves the elimination of water and aluminum chloride, resulting in our desired product. After completing the experiment, we must ensure proper cleanup. All reaction mixtures should be disposed of in designated organic solvent containers to prevent environmental contamination. And also, safety precautions are paramount. Always wear gloves and goggles and conduct the experiment in a well-ventilated area to minimize exposure to harmful vapors. So this experiment allows us to explore the reaction between azoxybenzene and various aromatic compounds in the presence of aluminum chloride. By understanding the mechanism and the significance of color changes, we gain valuable insights into electrophilic aromatic substitution reactions, and this knowledge is fundamental for further studies in organic chemistry. And as mentioned before, the main aim of this experiment is to test for the existence of aromatic compounds in our unknown, or to test its existence. And this is everything for this video, and thank you for your listening and your attention.